Hi everybody, welcome to the 107th edition of John News. My name is John Whitman and I'm coming to you from downtown Durham, North Carolina. I'm at Duke University's Quantum Computing Lab. It's called the Duke Quantum Center. You may not know what quantum computing is, and I don't really know either, so I thought I would find an expert to tell me about it. I talked to Isabella Gidding. She's a graduate student studying at Duke, and she works here at the Quantum Computing Lab. Let's see what she has to say. Hi, Isabella. Welcome to John News.
Hi, John. Thanks for having me on.
Hi. Tell me about your lab.
In our lab, we trap atoms and we shoot lasers at them to control them and do calculations for us. We have a bunch of lasers, and to control where these lasers go, we have optics. So optics can mean things like a mirror or a lens. So for example, here's one of our lights, one of our lasers. So this is at 493 nanometers. That means it's at a teal color, which you can see here. And these are mirrors, so the light will bounce off these mirrors and we can control where it goes.
That's neat. Can you show me around?
Yeah, definitely. Let's go.
Let's go.
So this table is where we actually trap our atoms. So as you saw over there, we have a bunch of lasers, and we can collect that light into something called a fiber. So this is the head of a fiber. So this is where the light actually will come out.
So before we go any further, what even is quantum computing? Can you explain it in a way that people can understand it?
So there's certain things that would take thousands of years to run on a computer that you and me have at home, for example. But with quantum computers, by using special quantum properties, we can speed up these calculations. So instead of thousands of years, maybe it'll take a few seconds.
Does quantum computing already exist?
It does, yes. However, it's very young, so it's still in the baby ages. We have quantum computers here in our facility that run and work. But one problem we have with quantum computing is we don't have enough bits. So in your computer that you have at home, information is stored in zeros and ones, which we call bits. Quantum computers, we call them qubits. Yeah, so we need to find a way to get a lot of qubits in order to run more important simulations. So when we work with lasers, we have to be careful. We don't want it to shine into our eyes. So we have something called laser goggles, and these help protect our eyes. You want to try wearing one?
Alright.
And I'll wear one with you.
Okay.
Woo!
It makes everything look yellow. I bet I look really weird.
Yeah, because it's blocking out certain colors of light to protect your eye from them.
Are lasers dangerous?
It depends how much power is coming out of the laser and at what color it is. If it's invisible light, like infrared or ultraviolet light, then you can't see where the beam is, so it becomes even more dangerous.
So why are you using lasers? What does this have to do with computers anyway?
So, as I mentioned before, regular computers have information stored in bits, zeros and ones. Here we're using atoms. We pick one of these energy levels as our 0 bit, and we pick a higher level as our 1 bit. And the lasers, we shine them onto the atoms, and it controls how excited these atoms are, so we can control which energy level the atoms are in.
So what does an atom look like?
My colleague, Jameson, he's a fellow grad student.
Hi.
He's actually working on some atoms right now. He can show you what they look like.
Yeah. We need to, so the naked eye, you can't see atoms typically. But here we can take some lenses to gather a lot of the light that's coming out of the atoms, and then we can focus that light onto a camera.
So he mentioned that we have to focus light onto the ions to see them.
Yeah.
And we do that with something called a lens. So this is like what you have in your glasses right now to help you focus light onto your eyes.
Yeah.
So we can see at what point the light will focus. So one of the things Jameson was talking about was he showed you the image of our two ions. Yeah. So these ions are actually inside this thing right now. So this is what we call a vacuum chamber. So because there's no air in this vacuum chamber, the ions are alone, so they're isolated from their environment. So from us.
Yeah.
So the laser light is coming out of these fibers and hitting these objects, and then we aim them into our vacuum chamber where the ions live. So when you were talking to Jameson and you saw the ions, that was a live video of what's happening right now, and they're inside there.
Thanks for being on John News. This has been so much fun.
Ah, thanks for having me. It was awesome.
Bye.
Bye.
And that's the good news. Until next time, this is John Whitman signing off from John News. Click the like button and subscribe to my channel. Do it now! If you do that, you'll be as smart as a computer. It works for my dad. So long, everybody. Bye.